determining how many more amps you can draw from a 200 amp motor control panel, with existing motors drawing 43 amps on each incoming 480 volts leg, involves a few considerations. The answer provided is an estimate because a precise calculation requires knowing specifics about the motors already connected, such as their power factor, efficiency, and how the load is distributed across the three phases if it's a three-phase system. The simple answer is that you have approximately 157 amps, which is the result of subtracting the current draw of 43 amps from the panel's total capacity of 200 amps. This 157 amps is a rough estimate of available capacity. However, it's crucial to understand why this is an approximation and what factors influence the actual available amperage. Firstly, power factor affects the relationship between apparent power, measured in volt-amps, and real power, measured in watts. Motors are inductive loads, which means they cause the current to lag behind the voltage, and this difference is expressed as the power factor. A power factor of 1 indicates that the voltage and current are perfectly in phase, meaning all the power is being used to do work. A power factor less than 1 indicates that some of the power is reactive and doesn't contribute to useful work. A lower power factor means that for the same amount of real power, you'll draw more current from the panel. This increased current eats into your available amperage. Secondly, the efficiency of the motors also plays a role. Efficiency is the ratio of mechanical power output to electrical power input. Motors are not perfectly efficient, and some of the electrical power is lost as heat due to friction, resistance in the windings, and other factors. A less efficient motor will require more electrical power to produce the same amount of mechanical power. This increased power consumption translates to high current draw on less available amperage on the panel. Thirdly, the load distribution across the phases is important. In a three-phase system, the total load should be evenly distributed across all three phases to ensure balanced current draw. If one phase is heavily loaded while others are lightly loaded, the heavily loaded phase will be the limiting factor in determining the available amperage. Even if the other phases have plenty of capacity, you can't exceed the capacity of the most heavily loaded phase. In practice, it's not sufficient to simply subtract the measured amperage from the panel's rating. You need to account for these factors to determine the actual available capacity. Because of these factors, it is absolutely essential to consult with a qualified electrician to accurately assess your situation. An electrician can perform a load calculation that takes into account all of these factors and more. The electrician can measure the actual power factor of your existing motors, determine their efficiency, and assess the load distribution across the phases. They can also consider other loads on the panel, such as lighting and other equipment, and factor in any potential future loads. Only a qualified electrician can give you a reliable estimate of how much additional load your panel can handle without overloading it. Overloading an electrical panel can have serious consequences, including overheating, damage to equipment, and even fire. The electrical panels are designed to operate within a specific range of current. Exceeding this range can cause the circuit breakers to trip, which is a safety mechanism to prevent overloading. However, repeatedly tripping circuit breakers can damage them over time, making them less reliable. Furthermore, overloading can cause the wires in the panel to overheat. Overheated wires can melt the insulation, creating a fire hazard. It's also possible to damage the motors themselves by running them on an overloaded circuit. Motors can overheat and burn out if they are not getting enough voltage or if they are drawing too much current. For all these reasons, it's never worth the risk to overload an electrical panel. Always consult with a qualified electrician to determine the capacity of your panel and avoid overloading it. Other considerations to keep in mind include the ambient temperature of the location where the panel is installed. High temperatures can reduce the ampacity of the conductors in the panel. The ampacity of a conductor is the maximum amount of current it can carry safely without overheating. The National Electrical Code, or NEC, provides tables that list the ampacity of different types of conductors at different temperatures. These tables are found in NEC section 310.15 and its associated tables. The NEC also provides guidelines for directing conductors in high-temperature environments. Diarting means reducing the ampacity of the conductor to account for the higher temperature. The type of overcurrent protection used in the panel is also important. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the circuit from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a certain level. Fuses are one-time devices that melt and break the circuit when the current exceeds a certain level. The size and type of overcurrent protection device must be appropriate for the size and type of conductors in the circuit. The NEC provides guidelines for selecting the appropriate overcurrent protection device for a given circuit. These guidelines are found in NEC section 240. Furthermore, consider the voltage drop in the circuit. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Voltage drop is caused by the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or not operate properly. The NEC recommends limiting voltage drop to no more than 5% for power circuits and 3% for lighting circuits. The length of the circuit also affects the voltage drop. Longer circuits have more resistance and therefore more voltage drop. The NEC provides formulas for calculating voltage drop in a circuit. These formulas take into account the length of the circuit, the size of the conductors, and the amount of current flowing through the circuit. In summary, while the simple calculation of subtracting the existing amperage from the panel's total capacity provides a rough estimate of available amperage, it's crucial to consult with a qualified electrician for an accurate assessment. The electrician will consider factors such as power factor, motor efficiency, load distribution, ambient temperature, overcurrent protection, and voltage drop to determine the true available capacity and ensure safe and reliable operation. Ignoring these factors can lead to overloading, which can have serious consequences, including equipment damage and fire hazards. Therefore, always prioritize safety and consult with a professional electrician before adding any additional loads to your electrical panel.